So in this example, I'm assuming that you've already looked at the shortcut rules for derivatives, like the power rule and the sum and difference rule, the constant multiple rule. And we're going to apply that for a polynomial function. And in this one example, I'm going to break it down so that every rule, I make it really explicit where I use it. That's mostly in case you've never seen these before, because what usually happens is people internalize these rules and they just kind of do at least some of them automatically, like the sum and difference rule, for instance. So if you're watching me write out this answer and you say, gosh, I didn't need to write that out, or why is he breaking this down so much? Relax, you can skip some of these steps if you want. Okay, so I'm going to start by writing the function over again. So y equals 3.7 x to the fifth minus 253 x to the fourth plus 10x squared plus 7. And then the first thing I notice is the plus and minus signs. And I can break this function into, I guess, 4 simpler functions by splitting it up at the plus and minus signs. And so when I take the derivative, I should have the derivative of 3.7 x to the fifth, which I haven't taken yet, minus the derivative of 253 x to the fourth, which again I haven't taken yet. That's why I'm writing the prime sign still here. When I say I haven't taken it yet, I still have the prime to do, the derivative to do. Let's see, plus, and then 10x squared, and I still need to take the derivative. And the last derivative, I guess I don't really need to break this out, probably. I would just go ahead and say that's 0. The derivative of 7 is 0. So that part. And so what did I use? I used the sum and difference rule. That was the first step. Okay, for the second step, I'm going to use the constant multiple rule. And this says if you have a constant multiple times your function, you don't have to do really anything to the constant multiple. People say it goes along for the ride. And so the way that looks here is I'll just write it, and then still I'm not quite going to take the derivative all the way yet. So this is 3.7, and then the derivative still, I need to take it, of x to the fifth minus 253, and then I still need to take the derivative of x to the fourth plus 10, and then I still need to take the derivative of x squared. And that is the constant multiple rule. Okay, so finally, the interesting part of this, maybe the most important part really, is the power rule. And that says, and again, I really encourage you to think of this rule in words, not using a formula, the letter n, but it's a different n in each case. So you think about what the rule says in words. And what it says is, bring the power down in front, multiply it, and then subtract 1 from the power that's on top. So it's a 2-step process. So in this case, the 3.7 goes along for the ride. That was on the last step. I bring the 5 down in front, and then I subtract 1 from the 5. So again, just to make it clear, in each case I'm going to bring the power down in front when I take the derivative, that is, and then I will subtract 1 from the power. Okay, so minus 253 and 4 comes down in front, and then subtract 1 from the power, you get x cubed, and then plus 10 and subtract 1 from the power, or sorry, bring the power down in front, and then subtract 1 from the power, you get x to the 1. Now, it's a very reasonable way to leave this answer. I'm sure many people, though, would like to multiply the numbers together in front, and that's fine, and we can kind of clean up a little bit. So 5 times 3.7 is kind of hard. Let's see, 5 times 3 is 15. 5 times 7 is 35. Carry the decimal place over. I think it would be 18.5. Does that sound right? think so. I'll double check that. X to the fourth minus, and then let's see, 4 times 250 would be 1,000, and then an extra 4 times 3 would be 1,012. X cubed, and then 20, and then people don't usually bother writing x to the 1. I just wrote it that way this last time because I wanted to show what happened to the power, but usually they would just write it as just plain old x. Okie doke, so that's it. Again, you can skip probably some of these steps after you've done it a few times. The bringing down in front and multiplying step is the most important part, and people certainly usually skip the first step up here where it was the separating with the pluses and minuses.